Okay, imagine the guy who wrote Minecraft's end poem turning around and drop-kicking 50 years of cosmology. That's Julian Gough. His Substack post on the Blowtorch Theory shot straight to #1 on Hacker News, where techno-nerds discuss and usually kill a lot of ideas. Even big ideas investor Jim O'Shaughnessy called it a huge new piece, worth every physicist's time. So what's the fuss? Gough says the vast empty void in space are not accidents. They are burn marks, scars left when a trillion supermassive black hole jets blasted through the baby universe like cosmic flamethrowers. Sounds insane, but the James Webb Telescope keeps finding clues right where this outsider predicted. So, quantum friends, let's see if a playwright just torched the old dark matter story for good. For decades, astronomers have tried to explain the universe's structure with a model called lambda cold dark matter, or LCDM. It says gravity plus a lot of mysterious dark matter slowly pulls everything into shape. That should give us a fog of small, messy, young galaxies. But then we started seeing something else. Massive, mature galaxies popping up very early, as shown by the James Webb Space Telescope. These galaxies are too big, too early, too organized. Instead of a random cloud, we see a web of vast network filaments, nodes, and huge empty spaces. How did the universe build something so structured so quickly? The answer might turn everything we thought we knew upside down. Enter the Blowtorch Theory. Imagine, within the first 100 million years after the Big Bang, a trillion massive black holes form by direct collapse all at once across the universe. Each of these cosmic monsters starts blasting out twin jets, plasma fire hoses so powerful they carve giant holes through the thick, early universe gas. These are the universe's original blowtorches, actively sculpting its structure, not just waiting for gravity to slowly pull things together. And the best part? The process doesn't need any exotic new particles or dark matter, just black holes, electromagnetism, and the laws of physics we already know. Let's see how these cosmic blowtorches work. When a supermassive black hole switches on, it doesn't just sit there. It pulls in huge amounts of gas, spinning it up into a blazing hot donut. The friction and magnetism get so intense that two jets burst out from the poles, blasting matter away at nearly the speed of light. We see this even today. Look at the Fermi bubbles near the Milky Way. But now, imagine these jets millions of times more powerful, in a universe that's much denser and smaller. They push gas out of their way, inflating giant bubbles, future voids, right where we see them today. A trillion jets, a trillion bubbles all forming and merging like a million balloon animals. That's why 80% of the universe is empty space, voids blown clear by these ancient cosmic blowtorches. But that's not all. As these jets streak through the early universe, they lay down magnetic fields, essentially wiring up the cosmos. Think of them as electromagnetic tram tracks. Charged gas, plasma, can travel easily along these magnetic rails, but not across them. So, the filaments we see today, they are where these tracks cross, channeling matter into neat, glowing threads. This explains why the universe's filaments are so thin, so straight, and why even the vast empty voids have faint magnetic fields. The universe wasn't built by gravity alone. It's shaped by light and magnetism, an electromagnetic circulatory system built by those trillion ancient jets. Does any of this wild story show up in the evidence? Let's pin down some clues. Clue number 1. UHZ1, a supermassive black hole found when the universe was only 470 million years old, as massive as all the stars in its galaxy combined. Clue number 2. The Porphyrion jet, 23 million light years long, 40% longer than previous theory said possible. Clue 3. An ancient blazar, one of these jets, aimed straight at Earth just 750 million years after the Big Bang. Clue 4. Abel 496, a cluster showing nested Russian doll cavities, evidence that these jets can fire repeatedly, carving out structures over time. But any good theory makes predictions that could prove it wrong. Here are 3 ways blowtorch theory could be tested. The Square Kilometer Array, the world's biggest radio telescope, should see the scalloped walls of voids matching the footprints of ancient jets. Number 2, the James Webb Telescope should find even more of these super early blazars, dozens at redshifts greater than 9. Number 3, future telescopes might detect those faint fossil magnetic fields along filaments and void boundaries, exactly where the jets once were. If we don't find these things, then the theory will have to be rethought. Now, maybe you're thinking, wait, how could so many giant black holes form so early? And how could jets stay stable over such vast distances? Blowtorch theory argues that the initial conditions of the early universe, a smooth but subtly lumpy gas, make the direct collapse of black holes possible, all at once before any stars exist. As for the jets, new observations like Porphyrion show that they can remain focused for millions of light years, especially in a denser, earlier universe. And unlike theories that keep adding new particles to solve each new problem, blowtorch theory uses only known physics, just a new active twist on what those black holes do. So what does this mean? Maybe the universe is more like a living, evolving system than a random cloud of dust. Maybe it's not just gravity shaping these things quietly in the background, but a vast cosmic light show, jets, shocks, and electromagnetic rails, sculpting everything we see. A universe that not only pulls itself together, but wires itself up like a brain coming to life. So what do you think? Could the cosmic web really be the scar tissues of ancient blowtorches? Are we looking at the universe's own neural network? Let me know in the comments. And if you enjoyed this journey, don't forget to like, subscribe, and share with your friends. Thank you for watching, and as always, stay curious.